Welcome back, mathematicians. In section 3.5, we're going to go over equations of parallel and perpendicular lines. There's quite a few things we're going to learn in this section, but before we learn anything new, I want to draw upon your memory from last year's math course and what you learned about linear equations in Algebra 1. So as a warm-up, can you go ahead and write the equation of a line that has slope equal to 3/4 and that intersects the y-axis at 0, -2? So I'm guessing this is probably a very easy example for you, very easy warm-up, because pretty much every time you dealt with linear equations in Algebra 1, you use the slope-intercept form. And so if I just give you the slope and I give you the intercept, well, you just plug those in and you probably got y equals 3/4 x minus 2. So remember, slope-intercept form is y equals mx plus b, right? And so here is the slope, positive 3/4. Here's the y-intercept, -2. So let's go ahead and think a little bit more deeply about what this 3/4 number tells us. Okay, what does slope really tell us? Well, to think about what slope tells us, let's first think about what a line actually is, right? And so if I ask you to tell me, well, what is a line? I already told you in section 1.1, I think, that a line is something that is undefined. But what do you know about a line? What do you remember about a line? What are the things you remember about a line from Algebra 1? And there's usually two things that students tell me from Algebra 1. They tell me that a line, okay, visually, it extends infinitely on both sides, right? So it extends infinitely. And then algebraically, they usually tell me, well, y equals mx plus b, okay, where m is the slope and b is the y-intercept. So I want you to think of a line as a relationship. It's a relationship between two things that change, okay? So x and y are your two variables, right? Here's two variables, x and y, those are both variables. Variable, that means that they vary, they change, right? So x and y actually have an infinite number of values that they can take on, right? But the relationship between x and y in this linear equation, this linear relationship between x and y, okay, is determined by this thing right here, the slope. So the slope is the constant relationship that defines, it's the constant number that defines the relationship between the two variables x and y. Okay, so another way to think of slope is that as x increases by 1 unit, okay, no matter what x is, x can take on any sort of you can plug anything into x, right? And as x increases by positive 1 unit, well, what happens to y? Well, y varies with x in the amount of 3/4 of a unit, right? So the slope describes the relationship between x and y. So as x changes by 1 in this linear equation, as x changes by 1, y changes by 3/4. Since the slope is positive 3/4, x and y have a positive relationship. And so the way you visualize that is if you're graphing the line, right? If you're looking at the line from left to right, it goes upwards. So positive slope. So those are all good things that I want you to remember as we move into the geometry behind parallel and perpendicular lines. Okay, so recall that you learned how to calculate the slope, right? And you said that, or you learned that the slope is what? Rise over run, which is the change in y over the change in x, or delta y over delta x. And how do you calculate delta y over delta x? It's just y2 minus y1 and x2 minus x1. Okay, so in this example, we have this blue line. Okay, here's the rise, the change in y, and here's the run, the change in x. Okay, so what do we do? Here's the 2 points, the coordinates of the 2 points that were given. Okay, so we just do this. Slope equals delta y over delta x, which is 4. 3 minus minus 1 gives you 4, over 4 minus minus 2, which gives you 6. So the slope of this line is 2/3. Okay, so if you go to any point, you can go up 2, run 3, rise 2, run 3, right? Okay, So equations of parallel lines. Okay, parallel lines have the same slope. Okay, so if you look at this line again, y equals 3/4 x minus 2. What is the equation of the line that is parallel to that line, but passes through a different point, but passes through the point 0, comma 15? 0, comma 15. Now this point, before you do any calculations, this point 0, comma 15, where is that on the graph? Well, that is right on the y-axis, right? So all you would really have to do is just change this equation, the b part of this equation. So you could just do this with no calculations. You could just tell me that, well, Mr. Lee, this is easy. Y equals 3/4 x plus 15. So these two lines are parallel. Okay, and if you can imagine these lines, if you could visualize these lines in your mind, they have a positive 3/4 slope. Okay, so pretty steeply sloped. Okay, but this one hits the y-axis below 0. Okay, and this one hits the y-axis 17 units up higher at positive 15. Okay, so what is the same here? 3/4 and 3/4. The slopes are the same. So these are parallel lines. The perpendicular lines, recall that perpendicular lines, the slopes of perpendicular lines are opposite reciprocals. Now, that's a term that I like to use and many math teachers like to use, opposite reciprocals. There's two things that are given to you there. Opposite means opposite sign. So if one slope is positive, then the perpendicular line will have a negative slope. Okay, then reciprocal just means just flip the fraction, right? So if you have let's say that one of the slopes is 1 over a, then the reciprocal would be, the opposite reciprocal would be negative a over 1. Okay, so let's go ahead and look at an example. So here's our equation, y equals 3/4 x plus 15. Okay, what is the slope of a line that is perpendicular to this line? Okay, what's the slope? So this slope is positive 3/4. So the opposite would be negative. And then instead of 3/4, if you flip this fraction, you would get 4/3. So the slope of the, and I subscripted this perpendicular, so the slope of the perpendicular is equal to negative 4/3. So opposite reciprocal. Okay. Now the textbook also, and some teachers also, instead of just saying that the slopes of perpendicular lines are opposite reciprocals, you might hear them define the slope of a perpendicular line as the products are -1. Okay, so if you multiply 3/4 times negative 4/3, you get a product of -1. Okay, so either way is, you can think of it either way. Okay, so here's an example. Okay, so we have this complex diagram. We have 4 lines. Okay, we have line A, B, C, and D, and we have a bunch of coordinates on these lines. And we're asked to determine which of the lines are parallel and which are perpendicular. So how are we going to do this? Based on what we learned, we know that parallel lines have the same slope, and perpendicular lines have slopes whose product is -1, or slopes that are opposite reciprocals. Okay, so just calculate the slope of each one of these lines, A, B, C, and D, and then compare the slopes. So the slope of A is 1/3. Slope of B is 1 over 2. Slope of C is also 1 over 2. And the slope of D is -2. So comparing these slopes, you can see that B and C have the same slope, 1 over 2. So B is parallel to C. And then both of those have slopes whose opposite reciprocal is -2. So we know that B is perpendicular to D, and C is also perpendicular to D. Okay, so now let's put everything together. Okay, so let's write some equations of lines. So let's write the equation of the line that is parallel to this given line, y equals 2x minus 3, but passes through the point -1, comma 1. Now there's two ways to solve this problem. So first I'm going to go through it probably the way that your Algebra 1 teachers taught you, and the next I'm going to show you a preferred method for geometry. Okay, and here's what I mean. With the formula for the equation of a line, you learned that there's 3 forms, right? There's the general form or standard form. There is slope-intercept, which is the one you used over and over and over again. And the reason you used slope-intercept so much in Algebra 1 is because it's really nice for graphing. It really lends itself well for graphing because you can always just graph it by starting, graph the y-intercept first, and then just follow the slope, like up 1 over 2, up 1, whatever, right? So it's really nice for graphing. But in geometry, really the most preferred method and the most powerful method to use is the point slope form. Okay, and for many reasons, point slope form is much more useful in geometry. Okay, so we'll go over both of those. So first, let's do it the way you probably are most familiar with. So we're going to use slope-intercept form, which is y equals mx plus b. So the slope of our new line is the same as the slope of our given line. So this slope is 2. So the slope of our new line is also 2. Okay, so now all we have to do is find b. We can just plug this point in, negative 1, 1, into this equation to solve for b. Okay, and I'm not going to go, there we go, 3 steps, b equals 3. Okay, so then we just know that y equals mx plus b. Our m is 2, our b is 3, so y equals 2x plus 3. And that's probably a way that you learned that you're very comfortable with and very familiar with. Okay, here's the better method for geometry. Okay, what I want you to do is get familiar with the point slope form. Point slope form, and I'll derive this later on in the course, but this formula, which it might look a little intimidating right now, but it's actually super simple. It actually just comes from our definition of what slope is, right? Because slope is just equal to rise over run. And then if we just multiply out the x minus x1 minus x2 or x minus x1, okay, this is what we get. Okay, but I'll show you that in a different video. Okay, but this is the point slope form. Y minus y1 equals m times the quantity x minus x1. Okay, so x1, y1 is your point, and then x and y just stay as x and y. Okay, the slope of our new line is equal to 2. Okay, we know that from this equation right here. The slope is the same. Okay, and then here is the point that we're given. So what we do is we simply plug in this point, these coordinates for x1 and y1. So this negative 1 goes in right here, and this positive 1 goes in right there. So we get y minus 1 equals 2 times quantity x minus minus 1, which is the same as y minus 1 is equal to, now I'll go ahead and distribute the 2, 2x plus 2. Minus and minus makes plus. Okay, and now I just get rid of this. I just add 1 to both sides, so I get y equals 2x plus 3. So y equals 2x plus 3, y equals 2x plus 3. I get the same answer, same number of steps, same number of steps. Okay, so why is this so much more useful in geometry? Well, there's a number of reasons which later on you'll see. Okay, but if you're not familiar with point slope, I strongly encourage you to familiarize yourself with point slope and use it for the remainder of geometry. Okay. So now let's write the equation of a line that is perpendicular to this line. 2x plus y equals 2. Okay, now that's in standard form. Well, almost standard form. 2x plus y equals 2 and passes through the point 2 comma 3. First, let's find the slope of the original line. Let's find the slope of this. Okay, so to find the slope of that, I think the easiest way for you guys, based on what you learned in Algebra 1, is just rearrange this equation so that it's now in slope-intercept form. So all you have to do is get y by itself on the left side of the equation. So we just want to subtract 2x from both sides of the equation. So we get y equals negative 2x plus 2. Boom, slope-intercept form. So the slope of this is negative 2. Okay, and therefore the slope of our new line is going to be what? Opposite reciprocal. This is negative, so the opposite is positive. This is 2 over 1, so our reciprocal is 1 over 2. So the slope of our new line, or the perpendicular line, is going to be m equals 1/2. Okay, so now let's use point slope, because here we go, we're in geometry, right? We have a point, we have a slope. Let's use point slope. Okay, point slope, again, is y minus y1 equals m times quantity x minus x1. Okay, this 3 goes in right here. This 2 goes in right there. Okay, and then obviously this slope, 1/2, goes in right there. So the slope of our new line is 1/2. Okay, so y minus 3 equals 1/2 the quantity times the quantity x minus 2. Okay, y minus 3, let's go ahead and distribute the 1/2, equals 1/2 x minus 1. Add the 3 to both sides, we get y equals 1/2 x plus 2. So this is the equation of the line that is perpendicular to this line right here. Okay, so let's move on to a major new topic, and it is called directed line segments. Okay, so up until this point, when we've learned about lines, line segments, rays, etc., I've been telling you over and over again that, hey, a segment, it has no direction, right? So if you have a segment AB, doesn't matter if you call it segment AB or segment BA, there's no direction. Well, that's true until it does have a direction. Okay, so now we're going to talk about line segments that are directed line segments. So they are directional. We are moving in only one direction in this type of problem. Okay, so a directed line segment AB is a segment that represents moving from one endpoint to another endpoint. In this case, we're moving from A to B. Okay, so we're moving in this direction from A to B. The following example shows how to use slope to find a point on this directed line segment that partitions the segment in a given ratio. So they're going to ask you to find a point somewhere on this line segment. Okay, so you're traveling from point A to point B, okay, and you're going to stop to take a rest somewhere before you get to point B. You're going to stop and take a rest somewhere on this line segment, okay, such that the ratio of the two lengths that are partitioned is equal to some given ratio, okay, to some given ratio. Okay, so in order to divide this segment, okay, let's divide this segment into a ratio of 3 to 2, 3 parts to 2 parts. So in other words, we're moving from point A to point B, okay, and we stop somewhere such that this part is 3 and this part is 2, okay? And when I say 3 and 2, what I really mean is that if we really divided this entire thing into 5 equal parts, 5 congruent pieces, we will have traveled 3 of those pieces, and there's 2 pieces remaining. Okay, so if you think about that, that is just a ratio, that is just a fraction. Okay, we have traveled from point A 3/5 of the way from A to B. Okay, so we're going to call this point that is on here that has a ratio of 3 to 2, we're going to call it point P. And point P is 3/5 of the way from A to B. Okay, so how are we going to get 3/5 of the way from A to B? Well, it's 3/5 of the vertical distance, and it's also 3/5 of the horizontal distance. Okay, so I want you to think about that as we solve this. Okay, so 3/5. So first, go ahead and find the rise and run from A to B. This is just how you calculate it. Okay, find the rise and run, and don't simplify, just leave it as is. Okay, so the rise and run is the slope from A to B. Okay, so the slope is the rise is 8 minus 2, right? Y2 minus Y1, so that's 6. The run is 6 minus 3, or X2 minus X1. Okay, so our rise over run is 6 over 3. Let's just leave it as 6 over 3. Okay, you don't have to simplify that. Okay. Now, to find the x-coordinate of point P, so point P is somewhere on here. Well, maybe we're just going to estimate it somewhere around here. But to find the x-coordinate of P, what do we have to do? We have to add 3/5 of the run. So 3/5 of the run. So we're running 3. So we want to go 3/5 of the run, and we want to add 3/5 of the rise. Okay. So that is how we're going to find point P that's somewhere on this line segment. Okay. So the run is 3/5 of 3, okay, because the run, remember, is this bottom number. So 3/5 of 3 is 3/5 times 3, which is approximately 1.8, okay, 1.8. And then 3/5 of 6, 3/5 times 6 gives you 3.6. So the coordinates of P are, now what you do is you take 3 plus 1.8, okay? So here's your original, here's where you're starting from, point A. So 3, so your x-coordinate is 3, that's this 3. 3 is where you're starting from. So 3 plus, how much did you run? 1.8. So you have to add 1.8. So it's 3 plus 1.8, so you get 4.8. How much did you rise? How much did you rise? You rose from 2, then you rose an additional 3.6. Okay, you didn't rise the entire 6 units. You only rose 3/5 of 6, or 3.6 units. So the ratio, so the coordinates of point P are 4.8, 5.6, and the ratio of AP to PB is 3:2. Let me show you where that is on this graph. Okay, so point P is at 4.8, 5.6, right there. I drew a red dot. And this segment AP, okay, and is 3/5 of the way up this directed line segment. And this part PB is 2/5 of the way, okay, from A to B. So our ratio is 3:2. All right, let's go through one more example. So here's another example of partitioning line segments, directed line segments, excuse me. So now we have a directed line segment CD. So we're moving from C to D in this case, okay? So find the coordinates of point F along the directed line segment CD. So F is somewhere on here. You're traveling from C to D, and you're going down this line segment, okay? And your ratio is going to be 3:5, 3:5. So what does that tell you? 3:5. That tells you that F is going to be over here closer to C than it is to D, because you're going to have pieces that are 3:5. So I'm guessing, I don't know, somewhere in this region right here. Okay. So point F is 3/8 of the way from C to D. Okay, because the ratio is 3:5. That means this is 3/8, this is 5/8. Okay. So find the rise over run of C to D. So the rise is -8 and your run is 12. Okay, be careful with this graph because these go by twos. Notice it goes 2, 4, 6, 8, 2, 4, 6, 8. It's scaled by twos. Okay, so be careful with that. So now what do we know? Well, we know that we're going 3/8 of the rise and we're going 3/8 of the run. So 3/8 of the rise is -3. 3/8 of the run is 9/2, okay, or 4.5. So now we know the coordinates of point F are simply, well, start from your starting point. Remember, you're going from C to D. So your starting point. So be careful with the X's and the Y's. So let's do the X first. -4 is this coordinate, okay? But you're adding the run, the run. The run is 9/2, okay? So be careful. Don't just drop this -3 in there. That would be a mistake, okay? So -4 plus 9/2 is equal to 1/2. Okay, and then our starting point for the y coordinate is 5. And how much do we rise? A total of -3. So 5 plus -3 is 2. Okay, so what does that tell us? Our coordinates of f, okay, are 1/2, 2. And that gives us a ratio of 3:5. So there's f right there, 1/2, 2. And that is not very accurate. I apologize. This should be up here more. This should be up here, right about there. Okay. So F, this is our ratio of 3:5. Okay, this point should be right up here. It's very hard for me to locate these points exactly. Google Slides is not very exact. Okay. All right, now go have some fun. Here's your next 3 lessons. This lecture covered all 3 of those lessons, L37, L38, and L39. Enjoy. See you in the next video.